As you look at this problem, the first thing that you should notice is that there is an x on both sides, a variable on both sides of the equal sign. Whenever we have a situation like this where there's a variable on both sides, the fastest way to do this problem is to get all the variables on one side of the equal sign. So we have a 6x and we have a 3x, and we need to get rid of one of them. I always choose the smaller one. So in this case, 3 is less than 6. So I want to get rid of this 3x, and to do so, I'm going to have to subtract 3x because it's a positive 3. And then whatever we do to one side of the equal sign, we have to do to the other. So 6x minus 3x is 3x. Then we haven't done anything with that 4 yet, so we still have a minus 4. And then 3x's cancel out, and all we have left over here is the positive 2. I hope that from here you can see that this just looks like a two-step equation, which we've done multiple times. So from here, I would add 4 on both sides. We would have 3x equals 6, because 2 plus 4 is 6. The next step, I would divide by 3, and therefore x would equal 6 divided by 3, which is 2. The next thing I'm going to do is show you how to check your work whenever you have variables on both sides. I'm going to just copy this original equation down. And again, just like normal, we plug in that 2 where the x is. So it'd be 6 times 2 minus 4. And we're going to say if that's equal to 3 times 2 plus 2. So 6 times 2 is 12. I'm going to still draw this line. And then we have 12 minus 4 is 8. On this side, we have to solve it separately. 3 times 2 is 6. And then 6 plus 2 is 8. And then we notice 8 is always equal to 8, and therefore we know we are correct. X does in fact equal 2. Alright, on this second problem, again I'm going to draw my line. I want to get all the variables on one side, so we have 4y on the left and 3y on the right. Since I always move the smaller amount, I'm going to move the 3y, and I'm going to subtract it since that's a positive 3 on this side as well. So the 3's cancel, and I still have this 7 left over. And then 4y minus 3y is 1y. And we still have this minus 5. From here, again, it's just our two-step equation, so we'll do plus 5 on both sides. 7 plus 5 is 12. And then we have 1y over here. Now, you can go ahead and divide by 1, but we all know that you can also just erase this 1 because just a y by itself automatically means 1y. And so there we got y equals 12. We move that to the side. Now we're going to check our answer to see if we are correct. So we have 4y minus 5 equals 3y plus 7. Draw my line, and I'm going to plug in 12 where there was a y on both sides. And then after I substitute that in, I'm going to just solve both sides by themselves. So 4 times 12 is 48. 48 minus 5 is 43. 3 times 12 is 36. 36 plus 7 is 43. And because 43 is always equal to 43, we know we are correct. Alright, on this problem, I hope that as you kind of look at it, you realize that on each side of the equal sign, it's the same thing, 5x minus 7 on both sides. The nice thing about this is we know that whenever we have two things on each side of the equal sign, like whenever we're solving problems and it says 8 equals 8, like our first problem, or 43 equals 43, we know that these are always true. So it kind of goes the same way whenever, even if there's a variable. 5x minus 7 is the same thing as 5x minus 7. So when this happens, as soon as you see that it happens, you can kind of go straight to the fact that no matter what number I plug in there, it will be true. So another way, if you wanted to look at it, another way you could see is if I subtracted 5x from both sides. On the left side we would have negative 7, and on the right side, again, we would have negative 7. And negative 7 always equals negative 7. So, like I said, whenever this happens, we can say that there's infinite solutions to this problem. This would be your final answer. If you don't like to write that symbol, it's like a sideways 8. You can also spell infinite solutions. So, what infinite solutions means is that I could plug in a 2 for x. If I wanted to substitute 2 in for x, it would work. Or if I wanted to substitute in negative 3 for x, it would work. Any number that you can imagine, if you plugged it into this equation, both sides would always be equal. And when that happens, that's why you say there's infinite solutions, because no matter what you can think of, what number you can think of, if you plug it in, it will work. Alright, so now on this problem, whenever you kind of start looking at it, oops, that's the wrong button, but well, that works. Whenever you look at it, a lot of people will notice there's a 4x on both sides of the equal sign. So if I were to subtract 4x from both sides, these would cancel and these would cancel. I'd have 3 equals negative 5. Now, 3 can never equal negative 5. That's just not possible. So anytime we have an equation and it has two values that can't be equal, then that means there's no solution to this problem. There's no value of x that I could substitute in to make this equation work. I'd like to summarize kind of what it means to be infinite solutions or no solutions. First of all, the first rule of thumb is that there has to be variables on both sides of the equal sign. So variables have to be on both sides of the equal sign. The next thing that has to happen is that the coefficients, or the number with the variable, have to be equal, or have to be the same. And then the last one is that the constants have to be the same. And the constants are the numbers that don't have a variable next to them. When all three of these things happen, you can say there are infinite solutions to the problem. So to summarize, when to get no solution, or when you would get no solution for your answer, there has to be variables on both sides, which is the same as the other one. The next one is that the coefficients, which again are the numbers next to the variable, have to be the same. And then the last one is that instead of the constants being equal, the constants actually have to be different. And whenever all three of these things happen, you're going to get no solution. I wanted to point these things out because now that we're solving with variables on both sides, and you can get infinite solutions or no solutions, we start having students who start saying there's no solution to a problem when there is variables only on one side. And so I wanted to point these out so you guys can kind of see that there has to be variables on both sides of the equal sign. So if you look back at, if you get no solution and you look back at your problem and there's only variables on one side, then you know you've done something wrong. Now, I would like it if you guys could go ahead and start on the practice problems and see if you can do them. And if you get stuck, I am going to do the next couple problems on this video as well, but I would like you to try it first and then just kind of wait to see if you get stuck, or you can hit play and watch the video to double check your work if you think you got it right.